Okay, so now let's have a look at the questions. In this one, it says, so usually we want to be very careful about this paper because it really follows the, you have to watch for the significant figures and other stuff as well. So let's have a look at everything and see how we can make it super fun and easy and get the most out of it. So, pretty awesome. So now it says side a block. They've given you a full scale. As you can see, it's drawn at full scale. And then they give you length. So you have to use your ruler to do that. Right now it gives me 7.5, which is the length. And then for the width, it kind of gives me 2.5. Pretty awesome. Then I have the height, which is going to be, I think this is the height, which I believe is 1.3, about 1.3. Yeah. Okay. Then my buds, we have this part. The student uses the balance to measure the mass m of covered stack of slides. Write down the mass to nearest 1 gram. So it will be 57.9, right? And then we have the next one, which is you have to find the density. So 57.9 divided by, what were the values? 7.5 times 2.5 times. It's all instructional, so don't have to worry about it a lot. Okay. Then we are going to the next, where we have certain values like these. So let's go forward. I'm going to find it out. 57.9 divided by 7.5 times 2.5 times 1.3, which seems like just 2.3. Actually 2.4. Then the unit will be grams per centimeter cube, because these were in centimeter cube and that was in grams. Now the next, teacher write down the mass m and thickness of a single microscope slide on a piece of card. And the mass of the slide is m. Use your answer in information card to estimate the number of microscope slides and word in the covered stack. So if you check the thickness of this was only about, I think, 1.3, right? And here thickness of slide is 0.11 centimeter, and the mass of slide is 4 point. So the mass is 4.2. Use your answer to estimate number of micro slides in the cover stack. 1 second. What is this? This is the density of glass. All right. I think you have 4.9 gram mass, right? I think we got to divide this. And this would come out to be approximately 13.78. So I think it would be approximately 13 slides. Why 13 slides? Why am I down rounding it? Because it means 14 slide was, you can't reach 14, right? At least you'll have 13 then. Then use your answer information to obtain another estimate of eigenvalue in covered stack. In the covered stack, what do they mean by that? There is the covered stack. Okay, this is the covered stack. 57 point. We did that. We did that. You have thickness of this. Let's try that with the height. 1.3 divided by 0.11. I don't know what that is. Yeah, it will be 11 almost. For the covered stack, we were taking the length, the thickness. That's why I'm taking this, right? So, interesting question. This is a little bit tricky, but no worries. We can do this. Okay. Then, my buds, it says the quantities can be considered to be equal within the limits of accuracy if they're 10% of each other. So how do you find this? Basically, you have to use percentage difference formula. You always need to use that. Percentage difference is basically you use maximum minus the minimum value that you get divided by the mean of the value, maximum plus minimum divided by 2, and then 100%. That would give you the answer, okay? So if I were you, I would write 13 minus 11, 13 plus 11 divided by 2, multiplied by 100. So this is how you find out. Please write this formula if you don't know. 13 minus 11, then 13 plus 11 divided by 2, you have to take the mean, and then multiplied by 100%. So this is 17%, right? And the statement is that actually two quantities are not within the experimental accuracy, right? So you have to show the whole thing, whole process, please. Then says why one reason why estimated values n are different, and the reason it could be that maybe the slides do not have equal masses. That is a possibility, right? So yeah, or maybe they're not of equal thickness. They might have different thicknesses and stuff like that, right? So please check if you have any other idea, do share with me as well. Then we have question number 2. A student connects a voltmeter, measures the potential difference, closes the switch, records the voltmeter reading PQ. Opens on the diagram, draw the symbol of voltmeter connected to measure the potential difference across 220 ohm. So you're gonna connect the voltmeter with the correct symbol like this across PQ. On the the voltmeter shows the reading like that, and write down the reading on the table. So this reading is 2.1, 2.2, 2.3, 2.4. So 2.4, and we have to find the other things actually. So the current can be found out by only these two values because we have the resistance and the voltage across it. So we're going to use V is equal to IR. So the voltage is 2.4 divided by 220, which comes out to be 0. Now you see here we have 4 decimal places, so we will write the answer to 4 decimal places. 0.0109. So you have to make sure that column wise the values are correct. Okay. Then R LED. What is R LED? Let me see. All right, here QR. So we have the voltage across this. We have the current. We're going to use V is equal to IR again. 2.1 times 0.0109, and it has 3 significant figures. So we are also going to write 3 significant figures. Okay. Why though my answer is so less? Oh, I had to divide it, not multiply. Sorry. So it's going to be 192, 193 actually, not 192. Then, oh, they gave us the formulas as well, but we have already done it because we are so smart. And what about this one though? We have the current. We want to find this. We have the resistance. So current into resistance, 330 into 0.0076, 2.5, like that. Awesome. Now they say, actually we have done everything here. Wow, that's amazing. Party. This removes the 220 resistor from circuit, replaces with 330, and then connects, and then calculate the value. Oh, we have done it. As the resistance between P and Q changes, the current in the circuit changes. Use the resultant table to write a conclusion stating how the change in current affects the potential difference across LED and the resistance R of LED. So first of all, we're going to see. So when the resistance of PQ was increased, the potential across this was increased. And you see the potential across the LED reduced. And the resistance of LED increased. So this is what you're going to write. So you're going to say, increasing resistance reduced current, voltage PQ becomes larger than voltage QR, and finally resistance of LED increased. This is what the table says, states. You can check. Then it says another student uses a variable resistor to control current in the circuit, draws a symbol of variable resistor. So if you've drawn this, it's correct. If you have drawn something like this, it's also correct. Okay. Both the symbols are okay. Explain one advantage of using variable resistor. We do not need to disconnect circuit to replace resistance. That is the main idea. You can also fine tune it, right, according to your needs. That's something, you know. Then the next, the student investigates the image formed by converging lens. The practice setup. The student switches on the lamp, places the lens at a distance u, which is 20 centimeter from the illuminated object, rectangular hole, and the card. Okay. So I guess this is what he's talking about. This is u. Then says adjust the screen of position until the sharp image is formed. Measure to the nearest 0.1 the image distance from the center of lens to the screen. Interesting, huh? First of all, we're going to measure this distance to build a scale. So you see, on the actual drawing, this distance is 5 centimeter. That means 5 centimeter, 5.0 centimeter is proportional to 20.0 centimeter in the actual drawing. Then I'm going to measure this, and this is about 12.1. That means in the actual drawing, it would be 5 is to 20, then 12.1 centimeter is to what? Cross multiply, right? So that gives me 48.4. So first they say just measure the distance. Okay, we just need to measure 20.1. And then they have shown the scale, which I think we have already done. So they have shown the scale of full size. That's bad. I think our scale is wrong then, because they gave us the scale. So, all right, no problem. We can do that. So 12.1 times 5 is going to be the actual value. So this is going to be 60.5, and everything is good. Now comes the object. So illuminative object image drawn in full size. There are two ways in which object differs. Number one, it is magnified. And it is inverted. So this is the main thing that you guys need to remember. All right, then you have the magnification done here. And for the magnification, it says you need to use this. I think the best way is to find out the height. Just put, you can use a, to do this, I request you to use, what do you say, set square. So when you put a set square, it's going to give you exactly the height here. Right now, in my opinion, it is 1 point, from center to center, it is 1 point, so like top to top. So 1.3 is the height, but in the actual exam, make sure you put a set square here, okay? Set square is an object like this in geometry box. And also put the set square on that side. So here, we are like 3.9 centimeter height. So now we got to do this. 3.9 divided by 1.3. And this is going to be 3.0 magnification. right? So it's 3 times larger. Okay, then my buddies, let's go to next. This was pretty easy. Now we got to make the table. Sorry, the graph. For the graph, there are certain rules that I want to tell you. Number 1, you can write here. Do not make blobs. What are blobs? Blob is like if a point that you put in the graph is bigger than this size, it's considered a blob. So this is a good point. Let me put a green mark. And if you put a bigger dot or a cross like this is incorrect because this is considered to be a blob. So don't do that. Okay. Well, first of all, I want to tell you that. Next, we're going to talk about the next, which is you have to have a thin line and do not double it, which means you do sometimes you don't have the big ruler, so you do it and then you try to make it this way. This is a double line, so that's not allowed. Third, make sure to use greater than 50% of area. All right. So these are the few things. And about the best fit line is basically a line that equally divides points above and below. Number 1. And there's a misconception regarding this. And the misconception is that it must go through all points. It must go through most of the points. It is wrong. That doesn't work like this, right? So make sure that you don't follow this. Then, my buddies, let's go to next and start plotting. So we have to draw line of the best fit curve. So it will be a smooth line. Draw a smooth line. So take the points. I'm going to take the screenshot here. I want to basically come back again and again. Let's put it here. Okay, for the first point, we have on the y-axis, we have on the y-axis we have v. So write the quantity with the unit, and u on the x-axis in centimeter. So we got u 20 and then 60.5. So 60.5. What is 0.5 though? This 51, 52, 53, 54, 55. So 60.5 will be right here. That means 20 and 60.5. I'm just going to put a small cross here. All right. As you can see. So it should look like this in your actual exam as well. Like that. Okay. Then you have 25 and 37.2. 37, 35, 36, 37, 38. So it will be just about this one. Then 35 and 26.5. 35 and 26, 26 and 0.5. Then 45 and 22.0, 22.7. So it will be somewhere in the middle, almost in the middle. Then 55 and 20.9, 55 and 20, almost one.
सर मैंने आपको बिल सेंड कर दी
कितना है?
90,000
नहीं,
जी
wait a second. One moment, my kids. All right, kids. So now let's go forward. And then 60 and 20.2. 60 and 20.2 will be somewhere here. So then just make a smooth curve. Just make sure that it goes through like it's equally dividing points. So as you can see, 4 points are on the line and one is above, one is below. So that would be my line. Works like this. Then my buds, let's go to the next. And it says use your graph to find the value of V. When use 30, show that clearly on this. So we're gonna look at 30 and draw dotted lines. So it points here. Draw dotted lines. So it is 31. 31.1. 31.1 centimeter. Right? So make sure that you write that. 31.0. Sorry. Then 0.0 here because of precision. You have to keep the same decimal places as you see here. And in this, it's one decimal place. So you have to make sure that your answers are also in one decimal place. So basically, they will clearly write if you want to draw a line of best curve, like best fit curve or best fit line, they'll tell you exactly this point. All right, so you don't have to always worry about it. Then it says focal length. Use values U from D to calculate focal length. From D. Where is D? Oh, D here. Okay. So 30.0 times 31.0 divided by 30.0 plus 31.0. So, so then it's going to be 30 times 31, 30 plus 31, and it's going to be 15.2 again. So I want to make sure that I keep the same decimal places because we're doing this. Significant figures. Because there are 3 significant figures that we use. So we also answer should be in 3 as well. Okay. Then says state one technique you use when doing experiment to ensure the image on the screen is clearly focused as possible. So I think you should, and this is a common point you will learn with solving a lot of papers. But whenever you're doing a light experiment, make sure to perform it in a dark room. That would help you focus the image, right? So yeah. Any questions, please let me know, okay? Now, let's go to the next and talk about the final question, which I hate the most, because I write a lot in this. But there's certain things I want to tell you what to do. First of all, let's read what is it about. Hot water is poured into glass and allowed to cool down. Okay. Plan an experiment to investigate how the rate at which the water cools depends on the diameter of the water surface exposed to air. Right. So you have hot supply, set of different sizes and measuring cylinder to, I think, measure the amount of water. So what you're going to do is, I will write 1, 2, 3, 4 steps to answer these questions. You can answer these linearly as well if you want to, but I don't like to do that. Okay. So I will be answering this one first, then I'll answer this one, and then I'll write about the method, and then I'll write about the results by creating table. And finally, we'll write about the conclusion. Okay. And there's sixth point, which they never give you, but you have to write it. And that is any additional details. Additional details are like, how would you improve the experiment? And things like those. Now, just like your parents say, you may wish to do something, that actually means you have to do that. So let's suppose your mom says you have to make up your room. You may make up your room. But what she actually means is you have to make up your room. So that's what examiners do as well. They say you may wish to include the diagram, but actually you have to. So let's have it. So we're gonna make a couple of beakers. And then some bigger, some smaller. And then we will put a thermometer. Just draw normal drawings, no need to be fancy, because you just need to show the examiner that you understand. Like that. Okay. And some water. Like that. Okay. Now let's answer the questions. Oh, sorry. By the way, you have to label this as well. This is a beaker. This is a thermometer. And this is a water. Right. So what you want to do is, time to write this, huh? First, we're going to talk about the variables in this. Like I said, key variables. I would start with writing the independent variable. Independent variable. Independent variable is a variable that essentially means the one that you can control. I'm just going to write it here. Once one that you control. And in this situation, it is going to be the surface area of water exposed, because you can change the different sizes of container, right? Then comes the dependent variable, and that is the one that gets changed because of what you change. So gets changed automatically, right? Automatically. And that one, in this one, is obviously rate of cooling. These are the two things that you are actually testing things on. What you need to keep control variable means the ones that you need to control, so they should stay constant. And in my case, in my understanding, basically the amount of water must be same, because you want to make the investigation fair. Larger amount will carry more energy, You can also write initial temperature of the water. That is also important. And initial temperature of water. All right. So things like these work. So this is the first thing. Then I said move to apparatus needed. Apparatus needed. The one they haven't given, obviously, stopwatch to measure time. Vernier caliper to measure diameter and area, just diameter, and thermometer to measure the temperature. So these are basically the few things that you should be taking account, right? Too. So yeah. Any questions, please, here? Up till now, two parts are answered. Then we're going to talk about the next, which is, what was next? Let me see. Brief description of method, including what you will measure. Okay, so for the method, so I'm going to put the heading method, and then I'm going to write it. One. First of all, we are going to heat the water to a starting temperature. Fill the container. And using thermometer, measure the drop in temperature every I think 10 seconds. All right, that would be enough time, right? Then what you do, using the vernier caliper, we will write that at the end one by one. Okay, using vernier caliper, measure diameter, and then using and then divide it by 2 to find radius. Then what you do, find area equals to pi. Okay, I'm going to write that. I'm going to write it anyway. So find area using pi r square. That's how you're going to do it. All right, so this is the method. Then, because we've learned everything, how to, measure the two key variables, which are independent and dependent. Then moving on to the fourth one, which is results of measurement. So that's pretty easy. So you are to make the table. In the table, what you need is two things: the rate of cooling in degrees Celsius per second, right? So this is what you're going to do. Always write the units, okay? Or you can just write degrees Celsius if you're just taking temperature. Then area in centimeter square or meter square, whatever you want. All right, so it doesn't matter. Once you do that, then you have to write the conclusions. So for the conclusions, I would write something like this. I'd say the greater the area, surface area, the larger. Wait. First, we have to draw the graph, right? Because we need to plot it. Plot a graph. Now here, you always remember, plot a graph, rate of cooling, which is obviously the dependent variable on y-axis. So on y-axis in physics, it's just a convention to draw a dependent, and area on the x-axis. And on the x-axis, it's just a convention that we put independent. So that's a convention, right? Remember. So then compare the results. The rate of cooling must be higher when area is larger, right? So you can do this. That's how you're going to write the conclusion, okay? Now our 5 questions are complete. And I said add any additional details, which Ibrahim pointed out as well. You have to write about precautions and stuff. So here we're going to add additional details. First, write precaution, which is use thermal insulation when handling the beakers. Do not get burnt. Then repeat for each area the temperature drop, and take average. That's a common point. You can do that, right? Take a larger sample set with small intervals. So these are a few things you can write, and this is going to score you the full marks. So I hope everything is good. Okay. And that's done. So yeah, I will see you then in the next class. Have a nice day then. Bye.
Allah Hafiz, sir.
Allah Hafiz.